All right, so it is really important that you fix algebraically your functions so that you're ready to use the power rule. So these, I cannot take the power rule the way it's written. So let's just play with this. So I can see that this is 25x squared over 64x cubed, right? Because you're cubing everything in the denominator, you're squaring everything in the numerator. Okay, so this means that the function is 25 over 64, right, the number, and then if I'm looking at how the x's cancel, I see that I get 1 over x. So again, one more step before I take the derivative. I'm going to rewrite this as x to the negative 1. Now I'm ready to take the derivative. So the derivative, carry the 25 over 64 along, bring the negative in the front, and subtract 1 from the exponent. And there it is. All right, so it's important I be able to identify what the numbers are to peel off. So 2 and pi are numbers, and root 3 is a number. So all of that is multiplied times x. So just think of it as just an easier problem. If you had the derivative of 5x, you know that would be 5. So the derivative of ugly number times x will be ugly number. All right, so be really careful with separating this radical. So I can see this is going to be root 3 root t cubed. So I'm just going to go slow. Root 3, to rewrite this as an exponent, you know the fraction is power over root. So it's 3 over 2, power over root. Okay, so now I'm ready to take the derivative. So I carry along the root 3, bring the 3/2 down, subtract 1 from the exponent, so I get 1/2. All right, okay, so I don't need to tell you, but you should know that a, b, and c are constants. Okay, so again, I'm going to need to separate it. So let's just separate it. Ax squared over cx to the 4th plus bx cubed over cx to the 4th. And again, let's fix it up some more. So a over c are just numbers. And so then putting these two x's together, right, canceling, if I want to go slow here, you know they'd be left with an x squared in the denominator. This b over c is carry along, and the x's cancel, so I get a 1 over x. So taking one more step, it's up to you how many steps you want to take, but then rewriting x to a power is a necessary thing. So if you can get there quicker, great. Just going to take a couple of steps to make sure. Now I'm going to say, now I can find the derivative. A over c is a constant that carries along. I bring down the negative 2, and I subtract 1 from the exponent, negative 3. Then I'm going to carry this b over c along, and I'm going to be multiplying by this negative 1 in the front. So I get negative b over c, x to the negative 2. All right, finally we get to some application. I can find the equation of the tangent line. So remember, I talked about having a point and a slope, and using this equation was very, very helpful. Well, now we know the slope is the derivative, right? The slope will be the derivative at the point negative 2. Okay, so let's first just find f prime of x. So take the derivative of this, I get 4x cubed plus 3x squared. So that's a formula for the derivative. Now go plug in the number negative 2, and that will tell me the exact number m that will give me the slope. So I'd have 4 times negative 2 cubed plus 3 times negative 2 squared. So I'll get 4 times 8, negative 32, and then this is squared, so I'd have 3 times 4, which is 12, so I'll get a negative 20 as the slope, right? So this is f prime of negative 2. Remember, slope is always a number when I'm putting it into this equation of a line, right? So my m is negative 20, Okay, so that's my slope. So I need a point. I need an xy point. How can I find the xy point? Well, I know the x is -2. How do I find the y value if I know the x? How do I find the y value if I know the x? Don't I plug -2 back into the original function? I do. So -2 to the 4th plus -2 cubed. So this gives me 16 minus 8. So that'll give me 8. So that's the y value. Okay, so I can put it together. So y minus 8 is equal to -20 x plus 2. That's my equation of the line.